Lab 1, Charged Tapes. Everyday objects can easily become positively or negatively charged, either when rubbed against another object, pulled apart, or in the case of polarization, the objects don't even need to touch. It was established prior to this lab that like charges repel and opposite charges attract. A charged particle will also polarize a neutral object and become attracted to it. These two principles were applied to the early sections of this lab to determine the sign of the tape's charge. Many assumptions were made to calculate the excess charge on the tape and the number of electrons it gained or lost. In this lab, one charged tape was floated above another and the distance at which they were repelled was measured. Since it is known that the two tapes had the same charge, the force of gravity and the electric force on the top tape due to the bottom tape could be set equal to find the charge on the tape. The fundamental physics principles that apply to this model are as follows. Charged particles are created when there is an excess or deficiency of electrons. In the lab, this was done by laying down a grounded layer of tape and pulling another layer off of it. This created a positively charged tape with electron deficiency, whose derivation will be covered in the coming slides. One key assumption made was that the floating tape was stationary above the other tape, which created a zero net force. The only forces that needed to be considered were those in the y direction, the force of gravity and the electric force on the top tape by the bottom tape. These two were set equal and Q was solved for. Several additional assumptions were also made, one of which was that each tape was treated as a point charge. All charge was assumed to be concentrated at this one point, and each tape was assumed to have had an equal charge. Any humidity in the environment affecting the charges was ignored. When the charged tape was brought near the hand, it had a rather weak attraction. It also had a weak attraction when it was brought near a book, another neutral object. However, when the tape was brought near another tape, it was repelled. And when it was brought near a known negatively charged pen, it had a very strong attraction. This helped conclude that the tape was positively charged, resulting in electron deficiency. The first calculations done were to find the charge on the tapes. This was done by setting the electric force and gravitational force magnitudes equal to each other. The charge on the tape was then calculated to be approximately 9.6 times 10 to the negative 9 coulombs. The next set of calculations done was to find the number of electrons that were lost or given up. The area of the tape was found, and then the number of atoms able to fit within that area was calculated. Based on the charge of the tapes, the number of electrons lost was also calculated to be 5.99 times 10 to the 10 electrons. The number of electrons lost was then placed over the number of atoms, and a ratio of 1.5 times 10 to the negative 9 was found. The following code only further supported the hand-calculated results. The force of gravity and the electric force were set equal and then solved for Q. Each of the bodies within the code was created to be a point charge represented as a sphere, and each vector was represented in the code, the force of gravity pointing down and the electric force pointing up. The value of Q was also printed at the end of the code. The top sphere within the photo represents the top hovering tape. It has two y forces acting on it, displayed in yellow. The charge printed out at the bottom is 9.6 times 10 to the negative 9 coulombs, which is equal to the previously calculated result. However, one question that arose was what if the charges of electrons and protons were swapped? Nothing would actually change within this lab because alike charges would continue to repel and opposite charges would continue to attract. The tape would still be attracted to anything neutral and become attracted to the now positive pen. The tape would repel the opposite tape since they are both now negative and alike charges repel. It is important not to handle the charged tapes too much because your body acts as a connection between the charged tape and the ground. The Earth either passes electrons to the tape through you or takes them away. Though the model was simplified, we were still able to support physical principles with simple materials such as Scotch tape in our hands.